Okay, we're looking at the second year Stats and Mechanics textbook, and we're looking at exercise 6C, question 11. Okay, so we've got a nice diagram of what's going on here. So particle is projected from point A with an initial velocity of 5u, so that's 5u to the right and 4u up. So we don't know the actual velocity, but we know how fast it's travelling to the right compared to how far it's travelling up. And that's probably going to be enough for now. Moves freely under gravity, passes through B, and we're told that B is 12 metres above the ground, but we're not told. So we're told we're shown it on the diagram, and we're told there that it's 12J, but we're not told how far that is in the X direction. And we are told that part of the journey takes 4 seconds, and we're asked to find U. Okay, and it's always good when it's an exam question because we know how many marks it's worth. So this is worth 4 marks, so I'm expecting a decent amount of effort to get this. Okay, so let's think about the horizontal. Obviously, right is positive, and then the vertical motion, and up is going to be positive. Okay, so horizontally, I've got an initial velocity of 5u to the right. I have got it takes 4 seconds. And I don't think I know anything else horizontally. I might have missed something, so we might need to come back to that, but I'm not told how far it gets. So I think this would be a much easier question if I was. Okay, so let's think what we're told vertically. So the vertical velocity is 4u, it's moving upwards 4u. It's moving under gravity, so acceleration is minus g, so that's working downwards. Its displacement, now I need to be careful here, because its displacement compared to where it started isn't 12, because it started 20 metres in the air. So actually its displacement vertically from A to B is minus 8. So do be really careful there. So if I'm taking up as positive, at this point, it's 8 metres lower than it started. So it's minus 8. And T, I think it told me, was 4. So this is the useful one, the vertical motion, because, let's just move up a little bit, I think I've got everything I need here. So if I use S is ut plus a half at squared. So S I know is minus 8, U is 4u, and T is 4. So that is going to become 16u, 4u times 4, plus a half A, where A is minus G, so that would be minus a half G times T squared, so that's 16. So that's actually is going to be quite a simple equation to solve. So minus 8 is 16u, just going to the calculator, minus a half times 9.8 times 16. So I get that as minus 78.4. So if I add that over to the minus 8, I get, didn't need to put on the calculator, never mind, 70.4 is 16u. So U hopefully is 4.4 meters per second. Let's just double check that. Yeah, it's handy. Okay. Right. So might need to use that. So let's keep an eye on that value. Okay. So the value of K. Right. So this is only worth 2 marks. So this should be a bit easier. And I think let's sort of do it here because I think we've pretty much got what we need. So K is its displacement in the horizontal direction. Yeah, so that's what K is. K is its position at that point. So now we know, sorry, what am I writing there? That didn't confuse anyone. T is S, T is 4, right. Okay, so, and K is the horizontal displacement. So there is no acceleration horizontally because we don't consider air resistance. So I can just use that displacement is velocity times time, displacement is K, velocity is 5u, and I now know what u is. So the initial horizontal velocity was 22, and because there's no acceleration, that's its velocity throughout. So let's just stuff that straight in. So its velocity is 22 and 4 seconds, so K is 88. Again, let's just double check that. Yeah, that's good. Okay, and the angle the velocity p makes with the x-axis as it reaches c. Okay, that's not quite as bad as it sounds, I don't think. So c is when it hits the ground. So basically we want to find its velocity as a vector at that point there. So, and this is what, yeah, this is worth 6 marks. So this is going to be the biggest part of the question. Right, so let's go horizontally. And I don't know. Yeah, so I'm going to hit a bit of a dead end here. Right, so horizontally, I know the initial velocity is 22. We just worked that out. I don't know how long it takes. And I don't think I know how far it is to see. Let me just read the question again. No. Okay, so I think, so T, I'm just going to call T, and S, I don't know. So I think I might have to go, oh, what am I doing? I'm making life very difficult for myself. I don't care about any of that. Okay, so the velocity is going to be 22 horizontally. Right, ignore me. Okay, so let's try again. Right, but vertically I do need to worry about. Right, so vertically, the initial velocity upwards was 4u, and we've just worked out that u is 4.4. So the initial velocity upwards was 17.6. Acceleration is minus g. Displacement at c, so it started at 20, c is where it hits the ground, so at c displacement is minus 20, and I want its velocity. So I am going to use v squared equals u squared plus 2as. So v squared is 17.6 squared plus, so we're going to have negatives cancelling here, aren't I? Because I've got plus 2 times minus g times minus 20. So let's do that in the calculator. So v squared is 17.6 squared. So it's going to be plus 2 times 9.8 times 20. So negatives will cancel. So I'm getting that to be 701.76. Now I've got to be careful here. So I'm going to square root that. Obviously, when I square root, it could be plus or minus. Let's go to 3 something that bigger, 26.5. And obviously, if I go back to the diagram, well, what's happening at C? Well, I'm looking at its vertical velocity and it's clearly coming down. So at C, its velocity in the horizontal direction is minus 26.5. So at C, its velocity as a vector is 22i, because that's not changing that whole journey, and then minus 26.5j. But they were asking me about the angle. So the angle P makes with the x-axis. Okay, so it's traveling 22 to the right. It's traveling with a velocity of 22 to the right and 26.5 down. So, and obviously the x-axis is the horizontal axis like that, so it wants angle theta. So that's not a problem. I've got opposite and adjacent, so tan theta is opposite over adjacent. So theta is arctan of that, which is 26.5/22. Tan of that, so 50.3, and it's 50.3 degrees below. Oh no, hang on, no, sorry, ignore me. It's not, is it? Right, I think I need to rejig my, so I think I've got the right angle, but if it's coming in, so that's, sorry, I can't see the diagram anymore. So that's the direction it's traveling. So it's really, oh, well, that's space now. Okay, so let's try again. Right, so that's the direction it's traveling as it hits the ground. So it's that angle there. So ignore me, it's not below the x-axis. Yeah, oh, drop that out. It's not below the x-axis. It's, so that's how it's traveling. I'm not sure I'm trying to draw there. So that's how it's traveling. So it is going to be the same angle. Think about your alternate angles. So it will be, well, let's double check. It will be 50.3, but it's 50, yes, 50 to two significant figures. Okay, right, got there in the end.